as Guillermo was saying, I'm leading the communication and adoption group here in Sylva. And for today, the presentation, we want to divide these in 3 steps. The first, to explain the why it appears this project Sylva, our approach that we are having to solve the issues, and what we are delivering. So beginning with the why, doing a market analysis, and I think we all here work in the telecom world, we begin to see some challenge that remains to solve. And the telco cloud journey already began for some years, and we need to solve these issues. The first one is the siloed approach. So this historical model that doesn't fit multi-vendor approach to shift to a common cloud layer. And we've been seeing that for quite some years, and having different kinds of multi-vendor approach to have this common layer. Then, in terms of security threats, it's mandatory nowadays, and we are seeing the operators are increasingly threatened by hackers. And this is not only a market analysis; it is always also something that we are seeing in the market, and some threats. I'm from Portugal, and Vodafone Portugal just had an hacker last year that had a major outage during 2 days. In terms of network functions, so the new network functions require the cloud native infra. We are talking about, and some people here in the call are interested in the RAN, but also the 5G core and CDN. So this shift to VNF and CNF is not easy, and needs to happen in an homogeneous way. Last but not least, the lack of automation that we are still seeing, and in our daily activities here in managing and implementing and delivering services on top of telco cloud, to have the automation, this continuous innovation and this service automation to shorten the time to market. At the end of the day, we want to launch new services. We want to be faster, but also to reduce the OPEX in the operators. So having this, I think this is broad to everyone, these issues, it was created this group, Sylva, underneath the Linux Foundation Europe. It was created initially with Orange, Telefonica team, Deutsche, Vodafone, Nokia, and Ericsson. And the objectives of this project divides into streams. The first one, to release this cloud framework software that is tailored for the telcos and edge requirements that address the technical challenge of the industry layer of this ecosystem. So to begin this homogenization that we need, but also to develop a reference implementation of the cloud software framework and create this validation program for such implementations. Today we are going to talk on these 2 streams, that what is the status on each of the mission statement. Now I'm having some issues. So with the why, with the market, with the mission statement, what are the opportunities that we want to unblock with this project? In terms of technology, the threats that we have, technology backwardness and slow innovation, with Sylva, we want to bring open source instead of proprietary solutions. We want to simplify and automate also the operation models. In terms of business, we see a lock-in and high prices. We want to reduce the costs of this part with open source and this mutualization, but also the interoperability with these validation programs and large adoption. So everything works on different operators. In terms of ecosystem, also we see the threats of fragmentation. So the telco cloud, it's very fragmented, and the enter of the hyperscaler. So we want to have a common telco cloud technology that is best for everyone. It's good for the operators, but also good for the vendors, for the hardware vendors, for the system integrators. Everyone will win with this ecosystem, and the convergence of the telco cloud layer. The last one is in terms of regulation and security. So we all know that we have a strong regulation in the telecom sector, but also this high cyber risk. We want to be compliant with the European regulation, but also have these high security standards and guarantee that when we have this common layer to everyone, that we will guarantee the security. In terms of our approach, so what is going to be the five technical pillars that we are betting. The first one in terms of network performance. Sylva will enable this part and will guarantee that the network performance to answer these CNF requirements. We are talking here in terms of low latency and having this container as a service platform also on bare metal. In terms of distributed cloud, so we want for this to be in the bare metal automation, so the declarative approach using GitHubs and to manage thousands of heterogeneous nodes, but also in terms of multi-Kubernetes in optimized lifecycle management of many Kubernetes clusters in DCs. We know that the cloud is distributed, but we can help also in this to do the homogeneous of this distributed cloud. Security, it's a big bet, and also you'll see our structure that we have a working group dedicated to this part to be the best in class of security design, but also to answer the telco grade requirements. We want to be open source and standardized API. So we want to support multi-vendor, and we want for the most of the vendors to come to this platform to be tested and to make sure that they are compliant with every operator. So this will be support a multi-vendor CNF, but also boost market adoption. And the other one is the energy efficiency. That is also a stream that is going to be explained, that we will bet on this part to measure and optimize the limits of energy consumption. These are going to be the 5 pillars. And now to present the work groups under Sylva TSC, it's going to present and
Yes, thank you, Andre. So this is the current organization of the activities in the Sylva project. We have now 6 different working groups. The first one is the telco cloud stack, and there's the responsibility of developing the software that will be the basis of our telco cloud stack. Then we have working group number 2 that deals with the validation center that is related to the second main objective of the project, that is the validation of applications on top of the telco cloud stack. Then working group number 3 related to security. This working group is now analyzing the EUCS framework, that is a framework for the certification of cloud services that is produced by the European Commission, because we believe that the first requirement for having secure cloud services is to be sure that the software stack you are using for that services has this level of security. So working group number 3 is extracting from the general framework of the certification requirements related to the telco cloud stack. Then we have working group number 4 that deals with energy efficiency, and here the objective is to monitor the energy used by the stack and the applications on top of it. And in the future, the objective will be to optimize the use of the energy by the infrastructure and the application. Then we have working group number 5 that deals with communication and adoption. And the presentation you see is one of the results of this working group. And finally, we have working group number 6 that deals with the governance of the project and how this governance is evolving. for example, the topics related to the license agreement and so on. Okay, thank you.
Thank you, Giuseppe. Now, on what we deliver, Mathieu.
Yes. Hi, everyone. Regarding what we are going to work on for the working group number 1, it's more like a way to deploy Sylva and a way to manage the Kubernetes clusters. So what we want at the end of the day is really Sylva to be able to deploy and manage Kubernetes clusters on top of different infrastructures. We want to be able to deploy Kubernetes clusters on top of virtualized infrastructure, OpenStack and VMware. And we also want to be able to deploy the CAS layer Kubernetes clusters on top of bare metal servers. We do have this kind of requirements coming from operators and from CNF vendor to be able to support several flavors of Kubernetes cluster of infrastructure. So we choose to directly go with the cluster API project in order to manage the life cycle of the Kubernetes clusters. Thanks to cluster API, we will be able to have a single API to manage the Kubernetes clusters independently from the underlying infrastructure. But we also will be able to rely on infrastructure provider provided by the cluster API project, which allows us to deploy on OpenStack, on vSphere, on VMware, and on bare metal thanks to MetalCube. We are going to also to maintain 2 kinds of Kubernetes clusters. We want to be able to deploy vanilla clusters based on KubeADM, but we also do want to be able to deploy RK2 clusters. And Suzy and Rancher are part of the project, and they are working on a specific bootstrap provider. This is the name of the component in cluster API, to be able to deploy automatically, thanks to cluster API, an RK2 cluster. Maybe you can go to the other slide. Okay. This slide is a little bit outdated, but can I just share my screen quickly with up-to-date slide?
Sure, sure.
Thank you.
And also, I think it's valuable to share the gitlab.com. So definitely it's.
Yes, for sure, I will share it. Okay, do you see my slide?
Yeah.
Okay, great. So one, just continuing with this picture. What we have today and what we are going to release very soon, by very soon I mean at the end of the week, hopefully, or beginning of next week, is the ability, thanks to the Sylva client, to deploy RK2 or KubeADM clusters composed of several components. So we are going to use cluster API, as I said. We are going to deploy a management clusters on top of the infrastructure that you choose. We deploy the management cluster that will allow us to deploy then some workload clusters meant to host the CNF. So thanks to this management cluster and cluster API, we will be able to deploy several flavors of workload clusters. Some of them can be deployed on top of bare metal. Some of them can be deployed on top of OpenStack, and some other on top of VMware. We do include in this management cluster some components such as Vault to manage secrets, such as Rancher, especially for having a single web UI and for managing the access to the workload cluster, thanks to the proxy feature of Rancher. And we are also using some useful components such as MetalB or some DNS components that allows us to easily manage the workload clusters and so on. So in the workload clusters, those are meant to host CNF. So in those workload clusters, we are able to use some kind of specific telco features such as Multius, and we are going to introduce also usage of SRIOV and some specific telco components, I would say, that are asked by CNF to be able to correctly deploy the CNF on top of these workload clusters. One other key component in the stack is the GitOps tool. We are using Flux to deploy the management cluster, the workload clusters, and all the components part of those clusters. We are going to use Flux, and we really want in this project to adopt the GitOps way to manage the lifecycle of the clusters. This is going to be really helpful for operators, and it will allow to manage clusters at scale, because at the end of the day, especially if we talk about RAN use cases, about UPF use cases, such use cases demand a lot of clusters. So hopefully we will be able, thanks to the GitOps approach, to manage this kind of scale. Okay. And what we deliver in Sylva V0.1 is really a Helm chart that allows you not to deploy some component, but to deploy some Flux component, Git repository, Helm releases, customizations. These are Flux objects that allows Flux to then manage the deployment of all the Sylva components the GitOps way. Okay. So I can show you related GitLab project. Everything is open source now. In Sylva project, you will see a lot of subdirectories, subprojects. And what we are working on in the working group 1 is on Sylva Core, which is hosted the Helm chart and all the components needed to deploy Sylva. And we are also managing some side elements that are needed to deploy Sylva in a specific subgroup named Sylva elements. And in this working group, we are holding a specific weekly meeting every Tuesday at 3 p.m. CET. So don't hesitate to attend this specific weekly meeting if you want to get involved in the development of the stack. And we are also maintaining and participating into a specific Slack workspace that you can also connect to in order to contact all the dev team. That's all for me. Is there any question? No?
How to join those meetings? Is there any particular way we have to place we can access that?
Yes, for sure. I think if you go on Sylva project on the gitlab.com, there is a wiki page. Here you can see the meeting agenda and hopefully the link. Probably in the governance TSC meeting, we have the link to the weekly meeting.
I will put all the links in the chat. I'm preparing that.
Yes. Actually, it's not obvious how to attend. We should provide some links in order to access all those meetings easier. Can you provide the links, Cecilia?
Yes.
In the chat?
This is the last one in my message. The all meetings information. If you click on the last link, you will see all the informations for all work group under Sylva. So all the meetings are public, so you can access them without any problem.
Okay. There it is. It is on the wiki page of the governance project. On this home wiki page, you can have the meeting details to connect to it. Any other question? Okay, for me. Leave the floor to probably Luis for the validation center topic.
Yes, I can describe the validation center. I'm going to share my screen as well. I am Luis Velarde, by the way. Okay, can you see my screen? Please, can you confirm?
Yes, it's okay.
Okay.
Yeah.
So the validation center is about, well, first of all, it's not the program to test the Sylva development, because the previous working group, the Telco Cloud Stack, actually tests that whatever is developed is working, but it's about demonstrating, testing, or validating that it is useful. So it can be used by the network functions, because the network functions will be working on top of this Sylva platform that, as Andre commented before, it is a multi-vendor platform. So network functions or applications from different vendors should be capable of running on top of this Sylva platform. So as we have commented before, Sylva aims to release an open source cloud software framework that will enable the capabilities identified by the telco operators for telco and edge workloads in general. So we introduce there the features, the telco specific features needed by the different applications and network functions. Sylva is not requirements driven, it is actually implementation driven. So it's implementing something meeting the requirements from different organizations. The requirements that operators identify as needed for network functions, the requirements requested by several network functions to be deployed, but also the requirements, basically the requirements that are coming from the ANUCE, the Open RAN, or even the ENISA organizations and others. So in this case, the performance-related capabilities that Matthew has commented before, security that were commented as well. There's a specific working group on security and Open RAN. So once we have this Sylva, then we have to demonstrate that it is useful because network functions or applications can run on top of that. So the validation program is about that, about validating that the network functions can make use of this platform that is multi-vendor and incorporates these capabilities. And this validation program has two parts. The CNF validation, that is specifically what I've just commented, and another part that we call it the derivative stack validation, that is about confirming that any product, commercialized product that may be created out of this open source stack, it is also compliant with all the requirements and actually implements the same capabilities. This second part actually is not our focus right now because there's no, we are only creating the open source. Remember that Sylva is just an open source project and is creating an open source thing, not a commercial thing. But the time will arrive when anyone will create something out of this open source, and we will have to demonstrate that it actually works properly. So we will have then the second part of the validation, but we are focused on the first part. So repeating on this, we have two parts of the validation center, the CNF validation, which is our scope right now and what we are working right now, and the distributions validation that may come when time comes. And of course, not before we have an official release. So the CNF validation or current scope is about demonstrating that the network functions can work on top of Sylva stack. So we are actually working on pre-beta versions, but we plan to have this going on for the different versions or releases of Sylva. So a network function can be validated on the first release, on the second release, depending on the needs, no? Depending on the requirements or the capabilities that are expected by this network function. To do this, what we do basically is we take some hardware and we deploy on top of this hardware the scripts that Matthew has been commenting before, the Helm charts, just to deploy this Sylva. Once we have this deployed, then we deploy on top of this Sylva the network function, and we run a set of tests. These tests are not a complete certification. We purposely call it validation and no certification because running this or passing this doesn't mean, okay, you can deploy it in production and you are happy. No, this is just to demonstrate basically that the network function can be deployed. Functionally, it works and makes use of the capabilities that have been enabled for that network function. For instance, if the network function needs Multus, we can demonstrate that it can be deployed when Multus is enabled. It can perform as the network function should perform functionally, so accepts, let's say, input in a specific format protocol and generates output in the specific protocol, and make use of this Multus capability that was requested by the network function. We are not testing the performance and all the use cases and all the possible scenarios of the network function. This is to be tested by any operator in their pre-production or previous to production environments. This is a validation just to confirm that the network function has nothing preventing to deploy on a horizontal platform, and that Sylva has nothing preventing a normal network function that requires a given capability to be deployed, but not a complete certification. And important, we are not trying to reinvent the wheel. If there's any tests that we can reuse or leverage, we will use it. For instance, we are using the same framework as Anuket is using today to do the CNCF test suite based on FunTest. So we are reusing some of the existing work, and actually we are reverting back. If we identify some things that in these test suites is lacking, we will provide this information back to any interested organization. So this is our main focus, the CNF validation. Apart from that, probably by the second part of the year, probably by the end of the year, we will start probably the distribution validation. So if anyone generates a product out of this and is going to provide support or whatever for this, we have to demonstrate that it is basically working, so including the same capabilities as the corresponding release of Sylva. So to do that, we will just leverage the test that the Sylva release has performed. So what Matthew has been talking before, some tests to demonstrate that these capabilities are included. And we will do that based on either dummy CNFs that we will create. For instance, if we want to demonstrate that the given stack, the given distribution of Sylva actually is incorporating the capability to configure Multus, and this has not been forgotten, let's say, when creating the product, we can use a dummy CNF that requests Multus just to confirm that Multus is actually enabled and used by this network function, or use a previously validated CNF or application that makes use of the same capability. And the same, we will be leveraging existing annotates or any other organization assets. For instance, we will probably run the conformance testing that is already available from Annocate. But this, I again insist, this is only B2B, will only be done when we need to be done. So our focus is CNF validation. This is where we are actually working. What's the validation process? Validation process has two parts. Actually validates 4 different things. The first thing that we have to do is identifying, well, first of all, select the network function to be validated. And once it is validated, we create a team. And in this team, one of the members of the team should be the provider of the network function. And the first thing is to identify what are the capabilities that are required, because not all the network functions require the same capabilities that could be enabled in Sylva. Maybe some require PTP, case of Open RAN VDUs. Some require SRIOV, case of data plane related network functions. Some require Multus, some could be control plane related applications. Well, that will depend. And some require everything. So we have to identify what is required. Then once we have it, we will deploy a Sylva release and configure it, enabling the capabilities requested by this network function. Once this environment is ready, we will then onboard the network function. So deploy the network function and confirm it is deployed. So with this, we will do the first validation component, which is confirming it can be deployed and nothing is preventing from deployment. So the pods are active. And then once it is deployed, we will run the second part, which is testing that it is actually working. So it's not only deployed, but let's say if it is an HSS or a database, 5G database, it can subscribe users. Not millions of users, just a limited set of them, just to confirm that it acts actually as HSS and supports the incoming protocol, I think it's called R1 or whatever. So to do that, we have to identify a minimum set of tests, working with a network function provider to see how we can demonstrate that. Then define the steps and configuration required on the application once it has been deployed, and then create a set of scripts. We try to be as automatic as possible. If not, we will do it running manually, the injection of actions. And then we will see how the application network function is actually behaving as it should be. Once it has been deployed, we will demonstrate that it is running. So I insist this is a minimum functional testing that verifies that it can be deployed and whatever has been deployed is actually the type of network function that was expected. We are evolving even this validation process, and we are going to incorporate some additional tests. We are going to incorporate also to confirm that the specific plugins that or requirements that were requested by the network function are actually in use. Because if the network function says, I need SRIOV, and later on never reserves a port, that means that it really doesn't need to configure that. So let's confirm that it is using what is needed so that we have additional insight on how it can be used on this common platform. And also we want to run some tests coming from Annocate relating to cloud nativeness of the network function. But anyway, once it has been deployed and functionally has been working, then we consider it validated, and it's up to any operator to run any additional functional or performance testing before deciding on any production deployment or whatever. This part in light blue is outside of the scope of the validation process. This is just a review of the same thing. So the validation itself has a set of steps, but as you can see, there's three main areas: configuring the platform just to start onboarding, onboard, let's say deploy the set of Helm charts for this application or network function, and then run the functional testing. And we have defined a set of milestones where we run some scripts to confirm the thing is ready, the platform is ready, the application has been deployed, and the application is actually responding to the injected messages. And that's all. Same as Matthew was commenting, we also have a validation center GitLab community area. Let me show you if I'm capable. Yeah, here. As you can see, under Sylva, there's one area called Validation Center with this area. And here, for instance, you have a document describing everything that I've been commented so far. So the scope, how it all works and all that, and the process. And we have a set of meetings. Right now, we are meeting every 3 weeks because we are not that active so far to do it every week. Next one is the 13th of April, and here in this wiki, but actually it will be in the links that Theophil is going to provide to you. You have the invitation, and you will have the Teams meeting link to connect to that meeting. Also here in the wiki related to this validation center, you have the minutes from previous meetings. So I think that's all about and of course, how we decide what are the network functions to be validated. This is something that is open to anyone to propose who needs to be validated. So any network function provider, application provider is encouraged to promote itself, and any operator or integrator or whoever who thinks that a given network function is interesting is promoted to propose it. And that's all about the validation center. Any comment, question?
As there are some vendors around the bridge, Oracle, Fujitsu, maybe just confirm that this process is clear.
Yeah, makes sense to me. I don't know, Herlan, Kobe-san, I don't know if you've got any queries.
Yeah, I haven't gone through the detail on the wiki. I'll probably check on that detail later. But maybe a little bit back to the previous all the sites, all previous slides that presented earlier. So we have, I mean, like Sylva project has like 6 TSCs. Do we have like a little bit more description about each TSC's information, like previously shared by I believe Luis, right? Sharing about the validation center, but we have the other TSC. Do we have like some slides explaining on each TSC's activities?
Yes, you mean working groups, right?
Yeah.
Yes, correct.
There's one working group and one TSC and 6 working group. So
6 working group. I'm sorry. Yeah, 6 working group.
And you maybe Teophil can share you one TSC minute. In each minutes of TSC, you've got the detailed mission of each working group as a reminder.
Yes. So can you see my screen?
We have the slide describing the working groups as well. Every working group has some information.
Yeah.
So
yeah, sure. Okay.
it's on the governance part. Yeah.
Yes. Okay, so we can make another roundtable around all the work group under the TSC. So there is only one TSC composed of voting members from the 7 founding members of Sylva, which are Telefonica, Deutsche Telekom, Vodafone, Telecom Italia, Orange, Nokia, and Ericsson. But any company can join this TSC by applying. And you can anyway contribute to the project without being represented in the TSC. This being said, all TSC meetings are public, all the minutes are here in this. I will put you the link in the chat. And during the TS meeting, we review all the work done inside all working groups.
And each working group has got also a remind main goals. So you've got 3 lines to introduce each working group main objectives.
Yes. So there is the first working group that Mathieu presented before. It's about the cloud stack development. So it's all people developing the cloud stack. The second working group was presented by Luis around the validation center, the validation program, to validate CNF on top of the stack. Then you have a working group on security requirement. So the goal is to specify features for the Sylva project based on the requirements of the EUCS certification scheme that comes from the European Union Security Agency, which is called the ENISA. So it's a public draft certification scheme that we want to comply with. So then we have a work group on energy efficiency. So this work group just started. The goal of this work group is to measure and optimize the energy consumption of both the telco cloud layer and the application layer. And then we have a work group on communication and adoption. So the goal of this work group is to promote the project inside the telco vendor integrator hardware vendor ecosystem, and to manage communication actions. And
okay, thank you. Yeah, this is what I've been searching from the website. I couldn't find, but thanks for the link. I already opened it. Yeah. I'll figure out later. Yeah.
Okay, perfect. Maybe I can also make a focus on so how to contribute to this project. So the contributing file is under the Sylva repository here, the contributing file.md. In this contributing file, the link is already in the chat, by the way, for the contributing file. So the first step to contribute to the Sylva project is to sign a CLA, a corporate CLA, a contributor license agreement. So it's for intellectual property rights. So all the process to sign the CLA is explained here. It's very easy. Everything is online. You have to sign a document.
It's a classical Linux Foundation one, not specific to this project.
I think most of your companies are used to sign this kind of a corporate CLA. Then you can create a GitLab account if you don't have already one, and you can propose new feature or comment on issues, and you have a template document for proposing new features. Also, I wanted to share you this Slack channel. So we have a lot of people. We have more than 165 people in the general channel of the Sylva Slack. You have different channels. So one general, one for the development part of the stack. So if you need help to install the stack on your computer, to run it and so on, do not hesitate to send a message on the Slack. You will have quick answers. So yes, so you're welcome to contribute, test the stack, run it, and give feedback on the stack.
Yeah, and if you have some items on the CLA and so on, you in the general Slack stream, you can also ask that kind of question. So if there are no other questions around any topics, I will let the floor to André to conclude this session.
I'm puzzled. You want to conclude the session?
Yeah.
Okay. So, as communication and adoption, we are always available to receive your questions on the channels that you have here. I'm also available in my email. I can put it here for you to talk. This is for you to begin to look at this project. We want for you to participate. The main goal of Sylva, of course, as a one word, is to do this homogenization of telco cloud. But most importantly, we need people on this project. So the more the better. Here we can apply these. The more the better, and we are eager for you to participate on this open source project and to contribute to the success of this project. So don't hesitate to contact us to participate in the meetings. And if you have any doubts, you can have my point of contact to clarify you. Okay.
Many thanks, Andre, and to all the speakers.
I want to say is we also have a punchline that is good for this. That on every cloud has a silver lining. So we want the success of this project, and don't hesitate to participate to make any questions. Okay.
Yeah, we editor commented. Thanks.
Thank you.
Thank you
for your
very
time.
much, everyone. Thank you.
Thank you.
Thank you.
Bye.
Bye bye.
Bye. Thank you.
Bye bye.
Thank
you.
Bye.
Have a good
Bye.
day.
Good day.